Let us sketch couple of more functions which are periodic. You are showing it's periodic. This function I have written, f of x is x when x lies between minus pi and 0, and this will be pi minus x when x lies between 0 and pi. Let us sketch. This is x-axis and this is f of x. Y is equal to f of x. I have given minus pi to 0 and this is minus pi, 0 and this is pi. It means the next is 2 pi, the next is 3 pi and so forth. Here minus 2 pi, minus 3 pi and so forth. When x is minus pi, f of x is minus pi. There minus pi somewhere here. When x is 0, it is 0. And since this is linear function, a straight line like this. Come to the next. When x is 0, it is pi. This is pi. When x is pi, it is 0. So again a linear function there. So you can have a straight line like this. So this function is piecewise continuous. What do you do is, this is minus pi to pi. Total length 2 pi. Here pi to 3 pi. You are going to sketch this and this. Look, this. Similarly, you can sketch the function like this and this. Look. So this function, once you have shown minus pi to pi this function, you have to show this graph backward and forward, showing its periodic. Let me have couple of more. F of x is equal to minus 1, minus pi less than x less than 0, x lies between 0 to pi. So I will have this as interval which I have given, minus pi to 0, then pi, then 2 pi, then 3 pi, here minus 2 pi and minus 3 pi, and this is your f of x. Now when x lies between minus pi to 0, value of the function is minus 1, which is constant. Let me have minus 1 there. So constant function, it means this will be a line, straight line. When x lies between 0 to pi, it is 1, this is going to be 1. So if you have observed, there are linear function, the graph is something like this, the linear function. Here the functions are constant. So again, from pi to 3 pi, this is straight line there and straight line here. Similarly, from minus, there is straight line there and straight line there. A square wave is there, and you have to show its periodic. A square wave like this you are going to have, so it means this is a periodic function you are having. Next, couple of more, which is x mod. Another one, couple of function I am writing, x plus x mod. Another x minus x mod. Let me sketch 2 or 3 function, and then we are coming to the Fourier series, how to find. Now you are familiar x mod. X mod by definition. By definition, x mod is equal to minus x if x less than 0, and this will be greater equal to 0, x. This is the definition of x mod. Whenever you are having this x mod, you are going to use the definition. When x less than 0, it is minus x, and when greater equal to 0, it is plus x. I have written for 2 pi. All the functions which I am going to sketch are for period 2 pi. Let me have this minus x, and this is x. Anybody, if you are very good for adjusting minus pi and pi in this inequality, if you are going a little bit effort, you will see where do you put minus pi, where do you put pi, so that the inequality is not disturbed. Let me have minus pi less than x less than 0, x lies between 0 to pi. Look at that. I have adjusted minus pi and pi in this inequality without damaging the inequality. Look at that. X less than 0, this is as it is. X greater than 0, this is as it is. But I have the inequality there. Let me have again the sketch. This is minus pi to pi. Then 2 pi, 3 pi. And similarly here, minus 2 pi, minus 3 pi. And this is your f of x. When x is minus pi, let me sketch this function now. This function I am sketching. When x is minus pi, f of x is pi. Minus is already with it, and then you are going to have it is pi with this pi. When x is 0, it is 0. Come to this inequality. 0 when x is 0, fx is 0. When x is pi, it is pi again. So a linear function like this. Look at that. Since this is x, a variable. So you are going to have straight line like this, this and this. So V-shaped graph is for x mod. Again you are going to show its periodic like this. Again you are showing its periodic like this, So you have shown this function is periodic like this. Similarly, these are for your follow-up. Because if you are familiar how to apply the definition of mod in it and then how to sketch. So let me discuss one of the idea again. Let me sketch this. X, this will be plus x. When x is less than 0. When x is less than 0, it is minus, and already minus make it plus. And this will be 0 when x greater equal to 0. This x, when x is greater equal to 0, this mod is x. So x minus x is 0. It means this graph f of x can be written 2x minus pi less than x less than 0, and this will be 0. X lies between 0 to pi. So you have adjusted the inequality by putting minus pi and pi here, and you have seen this is the function you are getting by following the definition. So if I am sketching this is pi, this is minus pi. When x is minus pi, it is 2x. It is minus 2 pi. Here, minus 2 pi. 0, it is 0. So, since this is a linear function, a straight line, and then on the right half of the interval, 0 to pi, the function is 0. For 0, you are showing on your notebook, you can have a bold line there, or you can have showing like this, which is 0. So, showing this function a periodic, again you are moving the same way. This is 2 pi, this is 3 pi. This is 0, and this is something like that. And similarly, you are moving like this, minus 3 pi, minus 2 pi. This is 0, and this is going to be like this. So, this function you have make it periodic once you draw the function, and then this function is reproduced backward and forward to showing its periodic. So this is the Fourier series for a function whose period is 2 pi and each term having period 2 pi, where a0, an and bn are Fourier coefficients to be determined. Before determination the Fourier coefficient, we have one concept which is orthogonality of trigonometric system. Orthogonality of trigonometric system. This is a concept which is really important in order to find the Fourier coefficients. So a trigonometric system, 1 cos x, sin x, cos 2x, sin 2x, and so on and so forth. This system is said to be orthogonal in the interval 2 pi. Minus pi less than x less than pi. This trigonometric system is said to be orthogonal in this interval or any interval of length 2 pi. Any interval of length 2 pi. This system is said to be orthogonal. Then there are 3 steps to be noted. 2, 3. Minus pi to pi sine mx sine nx dx will be 0 if m is not equal to n, where m and n are integers. If they are not equal, then you are putting 0, but make sure you should understand the length of the interval must be 2 pi. It is 2 pi to 4 pi, 0 to 2 pi, anything. So that is I have written. But if they are equal, both are integer, if they are equal, you are getting some answer which is area under the curve. Similarly, minus pi to pi cos mx cos nx dx will be 0 if m is not equal to n. If m and n are integer, they are not equal, you are getting 0, but you are getting the answer if both are equal. Third step is minus pi to pi cos mx for all m is equal to n and m not equal to n. So in the third step, if m and n are equal, you are getting 0. If they are unequal, you are getting 0. But make sure the length of the interval must be 2 pi. So it is working. If I am writing 0 to pi, so it is not. It should be 0 to 2 pi. So it means length of the interval must be 2 pi, and then on m and n an integer. If they are unequal, you are not going to solve the integral. You put 0 and give the reference of orthogonality of trigonometric system. So this is going to be. Now I determine A naught and A n. I leave B n for the students to be determined yourself. Number 1, determination of A naught. Let me determine A naught. Because these are the Fourier coefficient I have to determine. Determination of A naught. Integrate equation 1 with respect to x from minus pi to pi. So I am integrating this equation minus pi to pi. F of x dx minus pi to pi is equal to A naught, which is constant. Let me take a note. Minus pi to pi dx plus in sigma n equal to 1 to infinity there. Let me have the bracket a n there. Minus pi to pi cos nx dx plus bn outside minus pi to pi sin nx dx and bracket close. So I am determining the A naught. The procedure is you have to integrate this equation with respect to x, integrate, and between the limits minus pi to pi each term. Minus pi to pi, minus pi to pi, and like this. Let me rub this side because this is everybody's familiar now. If they are unequal, it is 0. If it is equal, it will give you some value. So on the left, it is going to be minus pi to pi fx dx, and this can be written A naught. And x is minus pi to pi. Because when I integrate dx, I get x, and I'll put upper and lower limit later. N is equal to 1 to infinity. Let me have the bracket a n. And then integral of cos nx is 1 over n sine nx between the limit minus pi to pi plus bn is there. Integral of sine nx is minus cos nx over n between the limit minus pi to pi in bracket close. So I will have a naught there, upper lower limit. X is replaced by pi, put a negative sign, then minus pi. And this is plus sigma n equal to 1 to infinity a n over n there. Upper lower limit on x. So it is sine n pi minus sine minus n pi. So this is going to be 1 where n is an integer. N is 1, 2, 3, 4, 5, 6. So sine n pi equal to 0 for all n belonging to integer. So that vanish. Similarly, I am going to have this with minus bn over n. I am putting upper lower limit. Cos n pi minus cos minus n pi. Cos minus theta. Cos minus theta is cos theta. This you are, because this is even function. Cos minus n pi is cos pi, so that cancelled. So we are left with 2 pi a naught is integral minus pi to pi fx dx. The rest of the thing is vanish. So it means a naught will be 1 over 2 pi minus pi to pi fx dx. This is one of the Fourier coefficient we have to determine. We have determined. So we are having sine n pi is 0 for all n belonging to integer, and cos minus theta is cos theta because cos is an even function, so that can cancel. So we are left with minus and minus plus pi 2 pi a naught. So it means a naught is 1 over 2 pi minus pi to pi fx dx. So this is one of the Fourier coefficient, which is a naught, we have determined. Let us have a n. So let us integrate this, let us multiply this equation term by term with cos mx, where m is an integer, and integrate with respect to x from minus pi to pi. I am multiplying with cos mx dx, and this is minus pi to pi is equal to a naught, which is taken out, minus pi to pi, n equal to 1 to infinity. This is the bracket I have. I am multiplying this equation. Each term is multiplied with cos mx. A n is taken out, and I am integrating minus pi to pi cos mx cos nx dx plus bn is taken out, and I am multiplying cos mx sine nx dx, and bracket is closed. So I have multiplied. So this side is going to be as it is, minus pi to pi f of x cos mx dx is equal to a naught. So cos mx, the integral is 1 over m sine mx, where m is an integer. Upper lower limit that vanish. Let me have. This is a naught 1 over m sine mx minus pi to pi. So that vanish by upper lower limit because m is an integer. Similarly, plus one of the step of orthogonality of trigonometric system, whether m and n are equal, whether they are not, that vanish. This is going to be 0 if the limit is 2 pi minus pi to pi, and whether they are equal, whether they are not, that vanish. This is one of the step of orthogradity of trigonometric system. What we have is this is remaining. Sigma n is equal to 1 to infinity. When n is 1, 1 and m are not equal. That is 0. When n is 2, 3, 4, as soon as our n is going to be m, so we are getting the answer. This is am minus pi to pi cos mx cos mx dx. This is going to be. This is minus pi. Let me explain this in a bit another way. I am having sigma n equal to 1 to 4, for example. So I am minus pi to pi cos 3x cos nx dx. For example, if n is 1, 1 is not equal to 3, that vanish. If n is 2, 2 is not equal to 3, that goes away. When n is, let me have 4, 4 is not equal to 3, that goes away. But when n is 3, 3 and 3, both are equal, you are getting some answer. So this is the technique I am hearing. So there is no more sigma, because sigma is just for 1. For one value, when n is your m, so that is going to be both are m, you are getting some answer eventually. So this is am there, minus pi to pi cos square mx dx. And the integral is minus pi to pi 1 plus cos 2mx divided by 2 dx. Because cos square, sin square are written in half angle formula, and then you are using this. Am there, 1 by 2 there, minus pi to pi dx plus 1 by 2 minus pi to pi cos 2mx dx, and that goes. Now here, if I am integrating this, so it becomes 1 over 2m sine 2m mx, where m is an integer. Upper lower limit, that will give you 0. So eventually my answer is am half, and this is 2 pi, because its integral is x, and when you are going upper or lower limit, that will be 2 pi. 2 goes, and we are left with pi am is equal to minus pi to pi fx cos mx dx. This implies am is equal to 1 over pi minus pi to pi f of x cos mx dx. This is one of the Fourier coefficient, which is am we have calculated. Subscripts are going to be changed accordingly, because we are talking about n, so you can replace m by n. So this is the formula for one of the coefficient we have determined. Now this third one is as it is. In third one, you have to multiply equation 1 by sine mx. And sine mx, you multiply there, here, and then you applying the orthogradity of trigonometric system, and you will see the result will be something like that. Sine mx dx. So, summary. Let me write down the summary. After determination, the Fourier coefficient, and we have the Fourier series. We are having the summary Fourier series for a function of period 2 pi. P is equal to 2 pi. We were talking about 2 pi period. 2 pi period Fourier series is a naught plus sigma n equal to 1 to infinity a n cos nx plus bn sin nx. This is the Fourier series for a function whose period is 2 pi. A naught is 1 over 2 pi minus pi to pi fx dx, and an is 1 over pi minus pi to pi f of x cos nx dx, and bn is equal to 1 over pi minus pi to pi f of x sine nx dx. These are Fourier coefficient. Because here when we derive the formula we were using m, so that subscript is going to be changed accordingly. So we have Bn is sin nx, and here an with cos nx, where n is an integer 1, 2, 3, 4, 5, 6, so on and so forth. So this is the required Fourier series for a function whose period is 2 pi with a naught, an and bn are Fourier coefficient to be determined, which we have determined now.